All right, so number one, part A, we want to know how much the can hold. What am I asking about? The volume. Things that we know about this can. We know that the can has a diameter of 8 centimeters. And we know that the can has a height of 10 centimeters. If it has a diameter of 8 centimeters, what is the radius? 4. What shape is the can? A cylinder. How do we find the volume for a cylinder? Area of the base times the height. And what shape is the base? Circle. How do we find the area of a circle? Pi r squared. So pi r squared is the area of my base times the height of the cylinder. So volume becomes pi times 4 squared times my height of 10. So what is the volume for this can? 502.655 units. Centimeters cubed. All right, to help us with the next two parts, I have a prop. I have a can here for us to look at. I'm going to take the label off the can. Because part B says, find the amount of aluminum needed to make the can. What am I asking about if I want to know the amount of aluminum? Surface area. What part of the can is covered by aluminum? All of it. So both of my bases and this lateral area, the body of the can. So we're going to use the entire surface area formula that we have. What is the surface area formula for a cylinder?
2 pi r squared plus 2 pi r height.
Absolutely correct. 2 pi r squared plus 2 pi r height. Which part of that is my two bases?
2 pi r squared.
2 pi r squared, because pi r squared is how we find the area of a circle, and I've got two circles. Do we have everything we need to sub in and find our surface area? Yes. So 2 pi times my radius of 4 squared plus 2 pi times the radius of 4 times the height of 10. Let's do it a piece at a time. What is the area of the two bases? 2 pi times 4 squared. 100.531 plus the lateral area, the body of the cylinder.
It's the same.
251.327. Yep, came out to be different. And then we add those two together to get our total surface area. So my total surface area would be 351.858 units. Centimeters squared. Part C, find the amount of paper needed for the label. So I've taken the label of this can and I've cut it off. When I hold that label out, once it's been cut off the can, what shape is the label? It's a rectangle. How do you find the area of a rectangle? That's perimeter. I want to know the area. How do I figure out how big this is? Length times width, right? Well, if I look at this, that is exactly how tall my can is. So the height of the cylinder is one of the dimensions of my rectangle. The other dimension of the rectangle, this long side here, when I put it around the can, That's the part that has to wrap around that circular base. It has to go all the way around it. What do we call all the way around a circle? That's my circumference. How do you find circumference? 2 pi r. So length times width for my label becomes 2 pi r, because that's this distance here, times the height. So look at that surface area formula. Which piece of the surface area formula that we wrote in part B would give me my label area? 2 pi r times the height. This is my lateral area. 2 pi r times the height. And that is with a radius of 4 and a height of 10. And we've already put this in our calculators. That came out to be how much? Yep. 251.327 centimeters squared. Part D. The new design they are considering would double the height. What would the new height be then? 20. The new height.
Oh, so we had to solve it? I thought we had to write something.
Well, we do. We got to do both. We can't answer the question without the numbers, and then we have to look at those numbers and do some comparisons. What effect will this have on the amount of pineapple the can will hold? Well, if we're talking about the amount of pineapple the can will hold, that is volume. The amount of aluminum needed per can, that's surface area. And the amount of paper needed for the label, that's my lateral area. So let's see how this new height would affect that. Radius stays the same, everything else stays the same. So my new volume would be equal to pi times my radius squared, radius stays 4, times the height, which is now 20. So now let's take that and pop it into the calculator. What do we get for our new volume? 3.1, right? If we round it. 1005.31 centimeters cubed. So here's my new volume. Let's compare that to the old volume. The old volume was 502.655. The new volume is 1005.31. Did it get bigger or smaller? Bigger. How much bigger? It doubled. The can will hold double the amount of pineapple. All right, let's look at the aluminum now. So, new surface area, 2 pi r squared. My radius stays the same, so it's still 2 pi times 4 squared, plus 2 pi times my radius of 4 times my new height of 20. Did the area of the bases change at all? No. So that would still come out to be what for the area of the two bases together? 100.531 plus, now let's do this part, 2 pi times 4 times 20. I don't think so. 2 pi times 4 times 20. Yeah.
Will we be able to, you know where I said like surface area at the top? Will we be able to double that if the same answer?
Well, let's find out. We're checking to see if we would just be able to double it to get this answer. You said 251 for 2 pi times 4 times 20? 2 pi times 4 times 20. 502 point, did you use the pi button or?
I got 502.6.
0.655. Yep. You want to make sure that you're using the pi button on the calculators. So then we add these two together, and the new surface area would come out to be 603.186 centimeters squared. Is that what we get if we take the old surface area and double it? No. Did it get bigger? But it didn't double. So need more aluminum but not double. Why didn't it double? The volume doubled. Why didn't the surface area double? Yeah, the height, the change in height only affects this second part of the surface area formula. It didn't touch that first part. All right, let's look at our lateral area. New lateral area. This is the 2 pi RH. So 2 pi times my radius of 4 times my new height of 20. We already calculated this when we were talking about the aluminum. So that is 502.655 centimeters squared. Well, the old amount of paper was 251.327. Is this double? Yes. So you will need double the paper for the label. So the volume doubles, the lateral area doubles, but the bases don't double. So my surface area doesn't fully double because the bases stayed the same size, but the can got twice as tall. So it doubled the amount of paper I would need for the label. It doubled the amount of stuff inside the can, but it didn't double my aluminum amount. Still got bigger, but not double. What else would you guys like to see? Which one? Number 3, perfect. Once again, 2 requests. Candace is wrapping a Toblerone chocolate bar for her sister's birthday. The box is a right triangular prism. What are they telling me right there? What's a triangle? The base is a triangle. The bases are equilateral triangles with side length 4 centimeters. And the box is 15 centimeters long. All right, so from here to here is 15 centimeters. What does an equilateral triangle mean? They're all equal. So the end here, where I can clearly see the triangle, every side there is 4 centimeters. So 4 centimeters, 4 centimeters, 4 centimeters. Since all the sides are the same length, what can you tell me about the angles? They're all 60 degrees. In an equilateral triangle, my angles will always be congruent, and they will always be 60 degrees. So far, so good? How much wrapping paper will she need? What am I asking about? Surface area. So surface area, this is a right triangular prism. What's my surface area formula for a prism? Yes, 2 capital B plus pH. What does the capital B stand for? Area of the base. And what shape is our base again? Triangle. Well, how do you find the area of a triangle? 1/2 base times height plus perimeter of the base times the height of the prism. I want to look at this 1/2 base times height over here. I'm going to redraw that triangular shaped base here. 4 centimeters, 4 centimeters, 4 centimeters. Do we know how big the base of this triangle is? 4 centimeters right there. Do we know the height of the triangle? Nope. Height has to go from vertex to base. You can't pick one of the slanted sides to be the height. Has to make a right angle with the base. Do we know what the height of this triangle is? No. Because it's an equilateral triangle, what is that height doing to my base? Cutting it in half and making a 90-degree angle. So how big is each little chunk here then? 2 centimeters. We're not looking at the angles, we're looking at the sides. Could I use Pythagorean theorem to find that height? Absolutely I can. And we can do that, but I've got a faster way. Is 1/2 base times height the only way that we can find the area of a triangle? What'd you say? Something with sine. No. No. Not A plus B, but A times B. 1/2 A times B times the sine of angle C will also find me the area of a triangle. A and B are sides of the triangle, and C is the angle in between those two sides. Do we know how big at least two sides of this triangle are? Do we know how big the angle is in between them? Yes. So I can do it this way without having to do Pythagorean theorem, but either method will get you to the same right answer. I'm going to go ahead and do it this way because I don't feel like doing Pythagorean theorem right now. So my surface area is equal to 2 times 1/2. How big are my sides? 4. So times 4 times 4 times sine of, how big's the angle in between those two sides? 60 degrees. And then we have to do plus my perimeter. This is the perimeter of the base. What is the perimeter of the base? 12. The perimeter of the base, remember the base is a triangle shape. It's an equilateral triangle, so that makes it a regular polygon. We have 3 sides, thank you, that are 4 centimeters each, giving us a 12 centimeter perimeter. I'm writing right here. So 12 times the height. This is the height of the prism, not the height of my triangle. 15. It's a little misleading because they have this prism laying down and they called it the length. But when I am looking at a prism like this, when they talk about the height, no matter which way they have it oriented on the page for you to look at, the height would always have you standing it up on one of those bases. I can always tell what the bases are on a prism because they will never touch each other. They have to be parallel and congruent. The rectangles that make up the body of this box are touching each other, so those can't be bases. The two triangles will never touch, so those have to be my bases. So if I were to stand it up like this, this would be my height, which is that 15 centimeters. All right, let's calculate this now. What is 2 times 1/2 times 4 times 4 times the sine of 60 degrees? I got 13.85, and then I rounded it up to a 6 for that third decimal place. If you round it to 855, I'm not going to take off points for something like that. And then what about the 12 times 15? 180. So as far as wrapping paper to go completely around this box, I need 193.856 centimeters squared of wrapping paper. How much chocolate is contained inside the box? What am I asking about now? Volume. How do you find volume of a prism? Area of the base times the height. And I'm going to go ahead and find the area of the base the exact same way we did up above. 1/2 AB times the sine of angle C, and then times the height of my prism. So we have 1/2 times 4 times 4 times the sine of 60 degrees. Make sure you close the parentheses around that 60 before you put in the height of 15. And that would give us a volume of what? Should be quite a bit bigger than that. Let me see what got put in.
I did the first half.
Oh, just the first piece?
Yeah.
Now take that times it by 15. .923 centimeters cubed. Beautiful work. So just to reiterate one more time, there's absolutely nothing wrong with doing 1/2 base times height here. But you would have to come over and look at your triangle, your base, figure out what is the base of that shape, and then you would have to find the height. Now, if you're given the base and the height, I would absolutely use that. I wouldn't do 1/2 AB sine C if I know the base and the height of the triangle. You did plus, not times. What else do you guys want to see? Number 4? Absolutely. A pyramid in Egypt has a base with dimensions 150 meters by 150 meters and a height of 80 meters. So this is 150 meters. This over here is also 150 meters. My height right here is 80 meters. It's going to make a right angle with my base. We are supposed to find the volume, the surface area, and the lateral surface area. Let's do volume first. What's my volume formula for a pyramid? That's for a cylinder.
Oh, pyramid?
For a pyramid. 1/3 area of the base times the height. What shape is the base here? It's a square. How do we find the area of a square? Side squared times our height. So volume is 1/3 times my, how big are my sides? How big are the sides of that square? 150. So 1/3 times 150 squared times my height of 80. What is 1/3 times 150 squared times 80? 6 with how many zeros? No, should be more than 3 zeros. Five zeros. 1, 2, 3, 4, 5. So 600,000 meters cubed. Right, then we're supposed to find the surface area. What's my formula for surface area for a pyramid? Yep. So the capital B is area of the base. You told me my base is a square, so we have side squared for the area of the base. For the flat shapes, no, you have to know those. I'll give you the formulas that are on that half sheet, but you have to know how to find the area of a square, a rectangle, a triangle, and a regular polygon. You have to know those. All right, sides are 150, so we have 150 squared plus 1/2, and then that P is the perimeter of the base. So the perimeter of this base, you said was a square shape, which means it's a regular polygon. So number of sides times the length of each side. How many sides does the base have? 4 sides, and each side is how big? 150. So 600 is my perimeter. 600 meters. Times the slant height. So now we got to come over here and figure out what our slant height is. The slant height would come down this lateral face, like this. It's going to hit that base edge. Where it hits the base edge, it's going to make a right angle. But it's also part of this right triangle in here that's inside the triangle. So I'm looking at this right triangle right here. How big is this? 75. Because my base is a square, going from the center to the base edge is going to be half of my base edge length. We want to use that to find our slant height. So Pythagorean theorem, a squared plus b squared equals c squared. My height of 80 and my half base edge of 75, that's what we put in for A and B. Order doesn't matter. So 80 squared plus 75 squared equals my slant height squared. 80 squared is 6,400. What is 75 squared? 5625 equals my slant height squared. So then I add those two together, I get 12,025 equals my slant height squared. Then we take a square root of both sides. Not a good number. So let's leave it in its exact form. Let's leave it radical 12,025 for our slant height. So square root of 12,025. Let's do the easy part first. What is 150 squared? 225. How many zeros? 2 zeros. Thank you. I put my comma in the wrong spot. 22500 plus, and now I need all of this, 1/2 times 600 times the square root of 12,025.
32,897.568.
Absolutely. And then we add those two together. Oh, thank you. Gives us a total surface area of 55,000. Thank you, sir. 397.568 meters squared. All right, so we found the volume, we found the surface area. What else did they want us to find? Lateral area. Well, surface area is made up of the area of the base plus the lateral area. So the lateral area is all of this. And we've calculated that already, right? Lateral area is 1/2 times my perimeter of 600 times my slant height, 12,025. And so we get 32,897.568 meters squared. There is another way to calculate this, though, that I want to talk about because I really want you guys to understand what I mean when I talk about the lateral area. So the lateral area of this pyramid, that's these triangles up here. How many triangles are surrounding that base? 4. So I could find my lateral area by taking the number of triangles there are, in this case 4, times the area of a triangle. How do we find area of a triangle again? 1/2 base times height. That's my favorite triangle area formula. And this has to be the base of the triangle. And this is the height of the triangle. Why don't you erase my my highlighting in here, and I want to highlight the face of this triangle. So just looking at this one triangular face here. What would the base of this triangular face be? 150. So lateral area would be 4 times 1/2 times the base of my triangle, 150. And then I need the height of the triangle. Look just at this green shaded triangle. What were we calling the height of that triangle just a moment ago? The slant height. The height of my triangle is the slant height of my prism. Which we said was radical 12,025. I want you guys to put this into your calculator and see what you get. 4 times 1/2 times 150 times radical 12,025. What do you notice? It's exactly the same as when I did 1/2 perimeter times my slant height. So there's 2 different ways that we can find the lateral area. Either one of those methods is fine. So far, so good? Awesome. What else would you guys like to see? Number 11? Absolutely. A rectangular box contains 3 balls which lie flush against all of the sides. The volume of one ball is 14.137 cubed inches. Part A, what is the radius of one ball?
1.45.
You said 1.45? Tell me how you got there.
Because first I plugged in the volume, which is V equals pi r squared, I think. Right?
What kind of a shape are we working with when we talk about the ball? A sphere. What is my volume formula for a sphere? 4/3 pi r cubed, yes. All right, so let's take our volume, 14.137. 14.137 is equal to 4/3 pi r cubed. All right, we're going to work this backwards. We're going to get r all by itself. So the first thing I need to do is deal with this horrible fraction here. How do we get rid of fractions? Multiplication. A fraction means division, so I get rid of it with multiplication. What part of the fraction do you multiply by? The denominator. So what are we multiplying by? 3. So let's multiply both sides by 3. I'm going to cancel that out. It only cancels my denominator, which means I'm left with what part of the fraction still? I'm still left with that 4. So over here on the right, I have 4 pi r cubed. Over on the left, I have to do 3 times 14.137, which comes out to be 42.411. I cannot get rid of the exponent next. You have to get rid of any coefficients, any numbers that are being timesed to your variable before you're allowed to get rid of any exponents. Yes, we're going to divide both sides by 4 pi. Now, yellow calculators, I would recommend putting the 4 pi inside parentheses because sometimes my yellow calculators get a little bit weird. What is 42.411 divided by 4 pi, approximately? How much? You got to put the 4 pi in parentheses. 532.95. Make sure you put the 4 pi in parentheses. 42.411 divided by and then 4 pi in parentheses. Make sure you put this part in parentheses. 3.37, 3.375 if you round it out to 3 places. That's equal to r cubed. R cubed. If this was r squared, how would we get rid of the squared? Square root it. But this isn't squared, it's cubed. So we're going to need to do a cubed root. When it's squared, to undo it, we do a square root. When it's cubed, to undo it, we do a cubed root. Here's what that looks like. It has a little 3 here, and then a square root symbol. I will show you. So your calculators will do this. We first have to tell it what exponent we're trying to get rid of. Since we're trying to get rid of that exponent of 3, you're going to type a 3 in first. If you don't have a yellow calculator, I'll have to show you differently how to do it on your calculator. So these are yellow calculator directions. So put the 3 in first. Then you push the green second key. And then you push the button above x squared. This one right here that looks like the top part of a triangle. That should put a square root symbol on there, but with a little 3 in the front, just like it looks up here on the board. And then you type in 3.375. 1.5. You were close. What kind of units should we put with this? inches,
I did it a way different way.
which came close this time, but probably wouldn't come close with a different problem. So you'd want to do it this way.
Yeah.
All right. Does anybody need me to go through the directions for how to find a cubed root again? The exponent you're trying to get rid of goes in first. Then you push second and the button right above x squared. And then you put the number that's underneath that radical. What are the dimensions of the box? Okay, so what we found was this, 1.5 inches. And that's in all directions on this sphere, right? So how tall is the box? 3 inches. Because it'd be 1.5 inches to the bottom and 1.5 inches to the top. How wide is the box? 3 inches. All right, so height is equal to 2 times 1.5 inches. This is 2 times my radius. Width is equal to 2 times 1.5 inches, so 3 inches. Once again, 2 times the radius. Now I need the length of that box. How much? 9, yes. Because for each ball, we have a radius of 1.5, and we have got 3 balls total. So 1, 2, 3, 4, 5, 6 radiuses total times 1.5 inches. We get a 9-inch length. What else would you guys like to see? I heard 14. 14, all right, yes. Number 2. All right, let's do number 2 first, and then we'll go to number 14. 2 is really fast, which is why I'm going to do that one first, and then 14 is a little bit more involved, and honestly, I'm afraid I'll forget to do the other question if I don't do it right now. So let's go back to the front page, number 2, and then we'll go do number 14. Identify the solid formed by rotating each two-dimensional shape about the pictured line. So if I take something and I rotate it, rotate means to kind of turn it into what shape if I rotate things? It's going to turn it into a circle. So this corner right here is going to come down and come back up. Same thing with this corner here. It's going to go down and then it's going to come back around. And this edge is going to be right here. Cylinder. What about the next one? What do you think that would be? It's going to be a cone because this is going to come curving out and around here. And then it'll come back around if I could draw better. But this is going to stay affixed. It's going to look like this. So that would be a cone. What about this last one? A sphere. If I take a circle and I rotate it about that line, it's going to turn into a ball shape, a sphere. Yes, sir? You can't rotate something like this and end up with points on the ends. Let me see if I can demonstrate a little bit with this. It was not wanting to work super well earlier today. Let me see if I can get it to work. All right. I want you to imagine that this little flag doesn't have the cut out of it here, right? Let's look at it this way. It's going to spin like this. Do you see how it makes the circle on the end? And this side would also be a circle. So I'd have 2 circular bases. And then this part right here would be flat, And that goes around. So I'd have a circle here, a circle over here, and then it would be flat around this way. Does that make more sense? Whenever we take something and we rotate it, we will always end up with something that has a circular feature to it. I can't get a prism. I can't get a pyramid. I can get cylinders, I can get cones, and I can get spheres. Those are really the only types of things. We could make cylinders with holes in the middle. We could make cones with holes in the middle. But it's always going to be something with that circular type base to it, or it's going to be a ball. It's going to be a sphere. All right, 14 was the next one I was asked for. And 14, honestly, is a great one for us to go to after doing number 11. Joyce is giving a collectible set of 8 autographed golf balls packaged in a cube-shaped box and a Caitlin Clark autographed basketball in a custom display box as graduation gifts to her niece and nephew. Part A. If the box for the golf balls has a volume of 64 cubic inches, how much wrapping paper will Joyce need to wrap the gift? If I want to know how much wrapping paper, what am I asking about? Surface area. But they didn't tell me how big the cube is. They told me the volume of the cube, but they didn't tell me how big the sides are. Since I don't know how big the sides are, what should I call them? X. And because it's a cube, if I call the length X, how big would the width be? The same, it would also be X. What about my height? So X, X, and X all the way around, length, width, and height. A cube would be a sphere, cone, cylinder, pyramid, or prism. Be a prism. So the volume of the cube would be area of the base times the height. We know the volume of the cube, that's 64 cubic inches. What shape would the base of this cube be? A square. How do you find the area of a square? Side squared. So side squared times the height. How big are the sides of our cube? X. So I'm going to have X squared times the height. What's the height of our cube? X. What is X squared times X? X cubed. So 64 is equal to X cubed. I want to get rid of this cubed here. If it was a squared, I would do a square root, but it's a cubed, so I need to do a cubed root. So remember, a cubed root looks like a square root, except it has a little 3 out in front. It's very likely that it's on the test.
Have you seen the test?
I have seen the test. So the first thing you have to put in, you have to tell it what kind of root you're doing. So what number do we type in first? 3. And then how do I make it give me the radical that has the 3 there? Second, and we call this a caret. It's like the top part of a triangle. So second and the caret. Now it should give you a cubed root. Then you type in 64. 4. And hit enter. What'd you get? 4. So 4 is equal to X. So X is 4 inches, 4 inches, 4 inches. Am I done? No, they wanted the surface area. All I've done so far is figure out the dimensions of the cube, which is awesome because I need that to find the surface area, but it's not my final answer. How do we find surface area for a prism? Two times the area of the base plus the perimeter of the base times the height. And what shape is our base here again? A square. So 2 times side squared plus the perimeter of the base times the height. And how big did we figure out the sides are now? 4. So 2 times 4 squared plus, now I need the perimeter of the base. You said it's a square, which means it's a regular polygon. We have how many sides on our square? 4, and each side is how big? 4 inches. So what is 4 times 4 inches? 16 inches for our perimeter. So 16 times the height, which is 4. So the area of my two bases, 2 times 4 squared would be what? 32. Plus the perimeter times the height, 16 times 4, 64. So altogether, we are going to need 96 square inches, yep, inches squared, of wrapping paper. All right. So far, so good? All right. Let's look at part B. Now we have the basketball packaged inside of a cube. What do they tell us about this basketball box? I know how much wrapping paper it takes. So what are they telling me when they're telling me how much wrapping paper it is? They're telling me the surface area. What do they want me to find? Yep. How many cubic inches of space? We want to find the volume. What am I going to need to know about this cube if I'm supposed to find the volume? I need to find the area of the base, which means I need to know what about the base. I need to know my side length. I need to know my length, my width, and my height. This is another cube. So what could we call the length, the width, and the height? We can call them all x again. So surface area. We just did surface area for a prism up above. 2 times the area of the base plus the perimeter of the base times the height. We're going to do 541.5 equals 2 times what shape is the base? A square, so side squared plus the perimeter times the height. How big are the sides of this cube? X. So 2 times this would be x squared since it's side squared plus the perimeter of the base. The perimeter of my base, you said it's a square, so that means it's a regular polygon, right? All my sides are congruent. How many sides does my square have? 4, and each side is how big? X. So my perimeter would be 4x. So I'm going to put 4x in for the perimeter, times the height, which is x. All right, so I've got 541.5 equals 2x squared. I don't need the parentheses around it anymore. The parentheses just mean times, and this means times. What is x times x? What do we say if I take something and times it by itself? What do we call that? We square it. So x times x would be x squared. So this would be 4x squared. Both of these expressions have the same variable with the same exponent on it. That means these are like terms. If I have 2 of something and 4 more of the same thing, how many do I have? I have 2 apples in one pocket and 4 apples in the other pocket. 6. This would be 6x squared. When I've got exponents and coefficients, numbers that are being timesed, I have to get rid of the numbers out in front first before I'm allowed to touch those exponents. Divide both sides by 6. What is 541.5 divided by 6? 90.25 is equal to x squared. This one's a little bit easier for me to get rid of. How do I get rid of a squared? Square root it. Does this come out to be pretty? 9.5. So each of my sides is 9.5 inches. They wanted me to find the volume of this cube. So that's going to be the area of the base times the height. My base is a square shape, so this is going to be side squared times the height. The sides of the base and the height are all how big? So I have 9.5 squared times another 9.5, or that would be the same as 9.5 to what power? Cubed, yep, that'd be the same as 9.5 cubed. What is 9.5 cubed? Yep. 857.375 inches cubed. Nice work. You guys picked 12. You had me go over pretty much all the really hard ones. Very quickly, before I set you all loose, the answer key is already posted in Canvas. If you go to our Canvas homepage and you click on modules, you want to scroll down until you see today's module, Tuesday, May 14th. You have to go to the page here where it says Review for Module 12B Test Day 2. You click on that page. And then you scroll all the way down to the very bottom of the page. There's the answer key. I'm posting videos for every single class period, so if you had a question about a problem that I didn't go over, check out the other class period videos, and I probably have gone over it in one of the other classes.